right, let's talk about the rational zeros theorem. Rational zeros theorem is a way to kind of find rational zeros, as it kind of says, of a polynomial function. And it's going to take advantage of a couple of different things that we know how to do, but it's sort of an old test, so it's good to walk through, kind of see the advantages of it, but also to see where things like our calculator can really shorten up the process in the modern age here. So the rational zeros theorem basically just says any rational zero, so it's got to be real. So already we're ruling out the complex numbers, but any rational zero, also it won't have a square root stuck in there, right? Anything like square root of 2 or square root of 3 is not going to show up here. Basically the nice zeros, if you think of them that way, terminating decimals or repeating decimals, fractional zeros, are going to show up in this rational zeros test. And any of them will happen as ratios of the factors of the constant function, right? Or the constant term, right? So for us in our function up here, it's going to be negative 54. And the factors of the leading coefficient, so the factors of 14. If we set all of those factors up as rational numbers, right, we should be able to determine any possible rational zeros. There will be no rational zero that doesn't exist on that list. Now, the list is going to get kind of long, so let's go quickly here. The factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. Now, it might seem like a while to make there, but remember, the low end is usually the trickier part. So 1, 2, and 3 definitely went in there. 4 and 5 don't go in evenly, but 6 does. Then 7 and 8 don't, but now 6 times 9 would have been 54. So I can stop searching all of my numbers. I just need to know 3 times what? Well, that would have been 18. 2 times 27, and 1 times 54. I guarantee you none of the other numbers between there would have gone in because they wouldn't have had anything to multiply by, right? We don't have anything else on that lower end to pair them up with. Same thing goes for 14. We've got 1, 2, and then we skip all the way to 7 and 14. And now it comes the tricky part. Now we need to pair them up. Now I need to take all the factors of 54 and divide by all the factors of 14. So I went ahead and did that and just said, here are all my possibilities, right? We've got 1 divided by 1, 2, 7, and 14. 2 divided by 1, 2, 7, and 14. But really realize 2 divided by 2 was already on our list, right? It was positive or negative 1. And 2 divided by 14 was also already on our list. That was 2/7. Right? Or sorry, it was 1/7, right? It was already on our list. Same thing goes, 3 divided by all 4 numbers, and 6 divided by all 4, but again, 2 of them were already on the list, right? 6 over 14 is 3/7, and 6 over 2 would have been solid 3. Same thing works for 9 and 18, and then 27 and 54, basically pairing all of our factors up, right? And notice all the plus or minuses as well. We don't know if the zeros are going to be positive or negative, so we have to list off both of those things as well. Now, in the good old days, we would have taken all of those numbers, right, and thrown them into this function and seen which ones come out as zeros. Or we could synthetically divide one by one, right, and seeing which ones come out as zeros. But that is a really long task. So this is where, again, in the modern age, we would take advantage of our calculator. Let's go ahead and graph, right, our function. And the best part of our graph that we see crossing that x-axis basically happens in this narrow gap here between -3 and 2. So we get numbers, there's some number between -1 and 2, and there's also a 0 between 0 and 1. Well, what that did is it just narrowed our list down. I know that there is no 0 that's going to be less than a -2 or greater than a +1, right? Which means my 3s, my 9s, 27s, 54s, 18s, and 6s, they're all out, right? I also know I didn't hit any of those numbers right on the button. They're definitely in between. So I would say also, let's take out 1 and 2. There are no whole number answers, right? Also, because again, on the positive side, we're definitely not greater than 1 or less than -2. I can definitely take out 18/7 or 54/7. Now, 27/14, kind of working my way from the bottom up here. Technically, the negative might still work, but I would say the positive is definitely out, right? As well as, 27/2, that's way too large. 27/7 would be almost 4. Again, that's way too large. So we've narrowed that whole bottom list down to maybe that negative 27/14, because that would be slightly less, or slightly greater than, I should say, a negative 2. Okay. Then let's go 9/2 would not work, that's for sure. And again, the positive portion of 9/7 also would be out. Okay. Then let's go ahead and take a good look at it. 3/2, again, would be that negative 1.5. That looks like a pretty good possibility, actually. But the positive would be out. 3/7 looks like maybe that on the right side there. That could be a good possible positive number. But again, negative 3/7 would have been between 0 and negative 1. So that's out, right? Same thing with negative 3/14. And really, we could have gone back down to our negative 9/14. Also would not make any sense, right? That would have been between, again, 0 and negative 1. Negative 1/2, definitely out. Positive 1/2 is a possibility, although it doesn't look really symmetrical between the two. So let's kind of keep our eye on that one. Negative 1/7, negative 1/14, also all out. Negative 2/7, same thing, and negative 6/7, all out. Those positive numbers between 0 and 1 are kind of the tricky part. But I would also say 6/7, well, that would have been much closer to 1. I'm probably going to rule that one out as well. So now let's take a look. If I had to guess from the rest of those numbers, again, that negative 1.5, right, negative 3/2 right here seemed like a pretty good chance. So now let's go ahead and take our possibilities, right? And let's see if synthetically dividing doesn't work out too well. 14, 17, 120, 153, and negative 54. And I'm going to go ahead and synthetically divide out. So 14 times 3/2 would be a 21. Okay. Oops, and we're saying negative 3/2. Let's make sure we use that negative. I was going to say, we're just going to get really big positive numbers otherwise pretty fast here. Negative 21, though, makes for negative 4, which would be a positive 6, which is 126, which would be a negative, and I'm going to go ahead and take advantage of my calculator here. 126 times 1.5 is going to be 189 plus 153. Negative 189 plus 153 is going to be a negative 36, which times, again, a negative 1.5 would be a solid 54. And hey, look, we got lucky. There's our negative answer. Right? There's our negative solution. So one of the zeros of my function is definitely negative 3/2. Well, that means that all those other negative numbers, again, I can rule those out. So again, I can get rid of my negative 9/7, right, that I was considering, my negative 27/14 that I was considering. All those other negative numbers basically are a moot point. Now, taking a look at approximately where that is on the graph over here, I'm thinking a little less than negative 1/2. So maybe, we could try, positive 3/7. And I'm going to go ahead and just do my synthetic division directly off of what I already have. Remember, I can just repeatedly synthetically divide, which may be helpful in the long run anyway. So let's go ahead and try 3/7 times 14, right? Well, 7 goes into 14 twice, times 3 would be 6, is a 2. That makes for a 6/7, right? Well, immediately I'm going to start getting some pretty nasty numbers here. I'm thinking that's not working out too well. So let's get rid of 3/7. I'm thinking that's not such a great idea, right? So let's cross off that 3/7. I'm thinking that one probably not going to work too well. Maybe our 1/7, right? Could be a possibility, or possibly our 2/7. Let's try 2/7. Just throwing it out there, and let's see what happens here. Drop down that 14. 2/7 makes 4 is 0. Well, hey, that multiplies much better. And 2/7 times 126. Well, I better check that one out. Don't want to get the wrong number. And sure enough, hey, look, we got our 0. So again, 2/7 also turned out to be a good number, which again now takes out all of those other possible numbers we were using, right? And now we could even figure out from the 14x squared we now have left, plus 126, well, we don't need a fancy method anymore. I can just subtract my negative 126, divide by 14, which comes out to a nice negative 9. And my other 0 just became plus or minus 3i. So again, we've got zeros of our function at negative 1.5, 2/7, and plus or minus 3i. Again, I would highly recommend using your calculator for this. Again, you could also have found these decimals a lot more precisely, finding the zeros on your calculator, right? The whole left bound, right bound idea on a TI-84, or on many calculators, lots of other ways to go about that. But again, that's the process of rational zeros. I hope that helps you. Hopefully you can quicken up the process with that calculator a little bit. If you have any questions, talk to your teacher. Otherwise, good luck and have fun.